All right, hi everybody, my name is Andy. I'm a PhD candidate at IU in info science. The title of my talk is Make a Viz and Tavola. It's kind of a cryptic title, but it's going to make sense at the end, I promise. First, I want to talk about a piece of research that I was not involved in, but that is important for the theory I'm going to talk about later about investigating data visualization literacy. So in 2016, we took 273 subjects across 3 US science museums in Columbus, Ohio, New York City, and beautiful Bloomington, Indiana, where I happen to reside. So that's what I look like up here. Each of the subjects was shown 5 out of 20 different visualizations. And then each of the subjects was asked 5 questions per visualization. Here's one of the items. What do you call this type of data presentation? A choropleth map, which is, of course, a correct answer. So these are 4 answers that people gave that give us kind of an idea of the spectrum of answers. Density map, which of course is a technically correct term also. A map, which is a basic answer but still correct, and a chicken. At least one person that looked at this map was not able to name this as a map, which is kind of funny, of course, but also kind of depressing. Here is the full data set of visualizations that was used, encoded by the visualization type. You can see that there are some visualization types that are rather common, like a tag cloud in C1. We have a line graph in G1. But then we have some of those visualizations that are notoriously hard to read. For example, T2 is a tree map. We have a force-directed network layout in T4. And we also have a whole bunch of maps in there. For example, M2 is the choropleth map that we saw earlier. Here are some more of the results. So the question here was, does this type of data presentation look at all familiar to you? And we can immediately see that in both age groups, youths and adults, network layouts were by far the least familiar to people, whereas charts, maps, and graphs were relatively a lot more familiar to people. So the key insight here is subjects are less likely to be familiar with networks. Here are the results to the question, what do you call this type of data presentation? And we can also see that charts, graphs, and maps were identified as such in the majority of cases. Okay? Network layouts, however, were identified as such only in 2.6% of cases. Moreover, network layouts were most commonly identified as graphs. However, no charts and no graphs were mistakenly identified as network layouts. So the key insight is subjects have trouble naming network visualizations. In fact, many don't even seem to have a conceptualization of network visualizations as such. So to kind of bring this back to theory, a huge amount of frameworks and taxonomies have been proposed to help and organize the sprawling zoo of visualizations that is out there, where new visualization types come up every day, while also providing guidance when we design and deconstruct or read data visualizations, but also to facilitate teaching. So I want to talk a little bit about the centerpiece of the theory we develop in our lab, the Data Visualization Literacy Framework. Specifically, I want to talk about the process model. This is a cyclic process model about the design of data visualizations. Everything starts and ends with the stakeholders here on the left. So we go to the stakeholders, we identify the inside needs of those stakeholders, and then we acquire data, which we then analyze and then visualize. And this is cyclic, but there are also subcycles. So oftentimes, we get a data set, analyze it, and visualize it, but then we notice we cannot possibly satisfy those inside needs with this amount of data, so we cycle back, get a new data set, visualize again, cycle back, and so on. So when we visualize, we choose a visualization type. That's what part of the study earlier was about. We pick a reference system and produce a data overlay. Then we deploy that visualization, interpret it for our users, or else have our users interpret it themselves, and then go back to our stakeholders. So for the theoretical part, I want to now talk about 2 implementations of this data visualization literacy framework. And both of them were deployed to informal learning environments. And this is a video with sound.
run exhibit based on Minnesota's sportsology exhibit, and so they put in their information and they run across here, they run across our runway, and then they can see their data on an interactive display that we created. Yes. You beat your time.
Oh my gosh, I got 2 seconds. I just run, and I want to see myself in the data. So I'm actually looking for the cooking adult, which is right here. And look, I got a star. Not everybody gets a star. Some people, they get triangles. I don't like triangles. So I got that star. Look, it's pulsating because I'm still active on here. I have now time in seconds versus age group, but I don't really care about the age group. So let's do the height instead. So let's drag height over here. I want to know if the high people are really faster or not. Hey, this actually works.
With that thing is, if you run too fast, it doesn't pick it up. So you have to run fast and then slow down at the end. Yeah, working out the kinks.
Yeah, as you can see, we had a lot of fun with that exhibit. It was fun seeing my PhD advisor running along that track. So the software that we developed for the run exhibit, we also using for teaching. This is the MakerVis. This is a cloud-based, web-deployed visualization platform where you can upload mostly bibliographic data and then visualize it with 5 different visualization types. Here we see a temporal bar graph. I'm going to get back to this, to the teaching efforts at the end of this little talk. This is kind of a tour de force across the projects that we do. I want to now step away to a second project, and you have probably been wondering about what this is. This is a so-called moth. It is a miniature sculpture. If I press this button here, we have this actuation where we have 2 LED lights at the top of this front, along with 2 vibration motors for this kind of almost organic, grass-like, windy actuation. There we go. All right. That's fine. That's fine. So the moth is a miniature electric sculpture, and we consider it the child of a much bigger sculpture that we actually have at Indiana University in Luddy Hall called Amatria. Amatria is an architectural, artful environment enriched with infrared sensors sensing the proximity of foreign objects, meaning humans. Okay. So this is Amatria on her opening night just about a year ago. And you can see that it's suspended from the ceiling right in the middle of Luddy Hall, which is our new engineering building. We just moved in there about a year ago. So this is open to hundreds of people every day. And a very diverse set of people actually visits Amatria every day. So here on the top left, that's 3 gentlemen from Cook Medical, which is a pharmaceutical company. The top right is a ragtag group of people that came to one of our public tours. This is IU President Michael McRobbie with the First Lady. And this is a picture from my favorite tour I ever gave. This is a bunch of middle school kids. And they sent me a list of questions before, and it was several dozen questions like, is this a sentient sculpture? Can we make it angry? How do you know if it's happy or sad? And all of these questions that are really hard to answer if you really think about it. So we thought, how can we use data visualization to foster the curiosity of visitors and to kind of remove the shroud of mystery surrounding Amatria at least a little bit? And it is not a small task. This is a network layout of all the electronics in Amatria. And just to be clear, this little thing that you see here, that is a moth. So you see there are several dozen of these moths in there alone. There is also lights and speakers and infrared sensors. And not even visible to the visitor, a huge backbone of processing electronics, 13 Raspberry Pis, 3 laptops. So how do you even begin to visualize this in a way that is understandable, I don't want to say on the spot, but really in a very short amount of time? So what we did was we developed a 3D visualization, which we call Tavola, hence the cryptic name. Here we go. And Tavola is a 3-dimensional visualization that a user can control with a 3D camera. And so we see here a simplified model of Amatria inside a simplified model of Laddie Hall with a data overlay, encoding the location and type of sensors and actuators being lights and speakers and so on. The user can actually turn parts of this data overlay on and off. And when you do that, in a second, you're going to see, we're going to turn everything off other than the infrared sensors. You're going to see that the infrared sensors are only in those parts of the sculpture where there's actually people, which, of course, stands to reason. So the idea behind this scene really is to just illuminate the structure of the sculpture. We do not encode any kind of interactivity in there. This is really just to show what kind of electronics we have in there. A lot of careful work went into the design of this data overlay. I don't want to go too deep into details here, but the idea is that we take graphic variable types and graphic symbol types, and then we pair them to get all of these various meanings. And as Tamara Munson said earlier, color choice is actually a really important part there. And I didn't do that myself. We had a UX designer, specifically trained in UX design, who developed this color scheme for us. Here is an excerpt from the Atlas of Knowledge, which is a huge book coming out of our lab, which I put into my baggage to bring here. It's very heavy, but very, very fun to go through. So later in the salon, I would love for you guys to just come by and flip through it a little bit. And what this shows it's just a subset of all the different potential pairings you get between graphic symbol types and graphic variable types. And you also see that some of those are empty. Some of those cannot be paired meaningfully, or else it has not really been tested yet. So yeah, this is, of course, way more fun to go through if you actually have it in front of yourself in paper. Ever since we developed Tavola, we were able to deploy it to a kiosk. This is a kiosk right under Amatria. We just unveiled this a couple of weeks ago for Amatria's first birthday. And we are actively collecting user data from people to see, can we actually satisfy the insight needs of people that come and see Amatria? I want to show another scene out of Tavola. This is scene number 2. And this is a real-time data visualization. So this is a screen capture of Tavola. And in the top left, I overlaid live action footage. In a second, you're going to see my hand come in and getting closer to one of those infrared sensors. And as I do that, you will see that this real-time particle system here in the middle is going to turn red, and the particles are going to spread out a little bit more. This is real-time data coming from the sculpture into the application, kind of visualizing the sculpture getting more and more excited. Oh, something is getting closer to me. Okay, it's kind of like an emotionalization of data. At the same time, you're going to see this hand down here with the proximity index actually get closer to the infrared sensor. We spent months developing this, and then I demoed it informally to some of my colleagues in the lab. And the first thing that they thought they could do with this was to actually communicate with the sculpture, make the sculpture do something, which of course was never intended. All we wanted to do with this was, fostering exploration and visualizing data, not having a two-way communication. But there was the automatic assumption of almost all of our users. So that was a very sobering but a very enriching experience also. I mentioned our teaching efforts earlier. We are giving a visual analytics certificate. It's a professional certificate about data visualization starting again in October. I would love to talk more to you guys in the Q&A session and in the salon, and then you will also get to play with the math a little bit. Thank you very much.